In today's video, we are going to explore how metals are separated from their oxides, which is the form in which we typically encounter them in the natural world. But before we get into that, it is important to understand the meanings of two key terms: oxidation and reduction. Oxidation is the process by which a substance gains oxygen. For instance, if magnesium reacts with oxygen to form magnesium oxide, we say that the magnesium has been oxidized. On the other hand, reduction refers to the process of losing oxygen. So, if we take magnesium oxide and break it down into magnesium and oxygen, we are reducing the magnesium because we are removing oxygen from it. Most metals are relatively reactive, so when they're exposed to oxygen in the air, they tend to undergo oxidation and form metal oxides. A good example of this is iron, which naturally reacts with atmospheric oxygen to form iron oxide, more commonly known as rust. Because oxygen is so plentiful in the atmosphere, most metals on Earth will have been exposed to it at some point and will likely be found in their oxidized forms. There are exceptions, however. The very unreactive metals, such as gold, do not oxidize easily and are often found in their pure, uncombined form. Although metals can also be bonded to other elements, being bonded to oxygen is by far the most common, and we need to know how to reverse this bonding in order to retrieve the pure metal. Since we already know that reduction means the removal of oxygen, our goal is to reduce these metal oxides to obtain the pure metal. One of the most efficient and cost-effective ways to do this is by reacting the metal oxide with carbon. The concept here is simple. The carbon will steal the oxygen from the metal, thereby forming carbon dioxide and leaving behind the purified metal. For example, when copper oxide is heated with carbon, the reaction produces copper and carbon dioxide. In this process, the copper is reduced because it loses oxygen, while the carbon is oxidized because it gains oxygen. However, this method does not work for every metal. It is only suitable for metals that are less reactive than carbon. This is the reason carbon is included in the reactivity series of elements. By referring to this list, we can see that metals like zinc, iron, and copper can be extracted from their oxides using reduction with carbon. But for metals that are more reactive than carbon, this method will not work. For these more reactive metals, we must use a different method known as electrolysis, which we will discuss in a separate video. Electrolysis involves the use of a large amount of electrical energy, which makes it a much more expensive and energy-intensive process. As a final example, let us consider the extraction of iron from its ore. After mining rocks from the earth and sorting out those that contain iron, we find that we are left with substances known as iron ores. An ore is a metal-rich compound from which a metal can be economically extracted. The most common iron ore is Fe2O3, which is a form of iron oxide. To extract pure iron, we must reduce this oxide to iron. By consulting the reactivity series, we observe that iron is indeed less reactive than carbon. This means we can use carbon to reduce iron oxide rather than relying on electrolysis. In chemical terms, we take Fe2O3 and react it with carbon. When heated, this reaction yields pure iron and carbon dioxide. Once the equation is balanced, we have a straightforward method for extracting iron from its or using reduction with carbon. That wraps up our lesson. If you found this explanation helpful, please give it a like, share it with your friends, and subscribe for more content. We will see you next time.